Hello students, welcome back to another algebra video. Same as usual, pause the video and try these problems in your notes. They come from the last video that we had. Now unpause the video to try them with me. So we are graphing the inequalities. So first thing I'm going to do is create a number line. And I'm going to put 0 on it. And I'm going to put the number I care about, which is the number in the inequality. So we have -8. Okay, next thing I'm going to do is put a circle on -8. Should it be open or should I color it in and have it closed? Which one do you think? Well, remember that because this symbol right here is strictly greater than, that's what we say when it is not greater than or equal to. Strictly greater than means that the circle needs to be open. So we're going to leave it just like that. All right, now, which way should this inequality point? The way that we decide that is, we know that b needs to be greater than -8, needs to be bigger than -8. So what are some numbers that are bigger than -8? Well, positive numbers are always bigger than negative ones, so 8 is bigger than -8. So we want our arrow to point towards 8, and 8 is over here. So that arrow is going to point this way. And we're going to make it nice and big and bold so there's no question about which way that arrow is pointing. All right, let's do another one. R is less than 1/2. All right, so I put 0 on here, and I put 1/2 on here. Okay, and I'm going to put a circle around 1/2, and because it's just less than, it's not less than or equal to, that circle's going to stay open. Okay, and now, which way should the arrow point? What are some numbers that are less than 1/2? Well, let's see, 0 is less than 1/2, -3 is less than 1/2, any negative number is less than a positive number, so our arrow is going to point towards all of the negative numbers, like -3, something like that. It's going to point this way, towards all the negative numbers. Now you'll notice that in these two examples, the arrow pointed the same way as the inequality. So that will happen. If your variable is on the left side of the inequality, the arrow will point in the same direction as the inequality symbol. But if you switch these, and you have x on this side and 6 on that side, your arrow points in the opposite direction. And the reason I didn't tell you this yesterday was because I didn't just want you to memorize, okay, arrow points this way, if variable's on the left, arrow points this way, if variable's on the right. Like, no, I don't want you to memorize that stuff. I want you to be able to think for yourself. Okay, if x is smaller than 6, if x is truly smaller than 6, where should the arrow point? I want you to be able to think for yourself and not just memorize stuff. The point of math class is not to memorize stuff. It's to be able to think for yourself and to solve problems. If this happens, then what else can happen? I want you to be able to think. I don't want you to just memorize and regurgitate. Okay, beautiful. So these are our graphs. So we have finished these problems, and let's move on to what we have for today. Today, we are moving on to section 2.2, which is all about solving inequalities using addition or subtraction. So, our learning target is that you know what it means to solve an inequality. What on earth does it mean when we say solve an inequality? And the success criteria is that you can solve inequalities using addition or subtraction. So, some important information. Just as you needed the properties of equality to produce equivalent equations, you can use properties of inequality to produce equivalent inequalities. And equivalent inequalities are inequalities that have the same solutions. So, This might look very similar. This might, or the words, adding the same number to each side of an inequality produces an equivalent inequality. So if I add c to both sides of this equation, then this is also a true statement. So it's just like what we learned about when we had x plus 3 equals 5, and we were allowed to subtract 3 from both sides because we did it from both sides and it kept our equation the same. It is the same thing if I have 5 is greater than 2. That is a true statement. If I add 3 to both sides, I get 8 is greater than 5. Still a true statement. If I add the same thing to both sides, it doesn't change whether or not the equation or the inequality is true. I can add the same thing to both sides of an equation, and I can add the same number to both sides of an inequality, and it is still the same. So, with that, we're going to solve an inequality using addition. So, I want to solve x minus 6 is greater than or equal to negative 10, and then graph. So it says solve, then graph. So you know what? I'm actually going to put a number line over here so I don't forget to graph. Because a lot of people, they solve it, but then they forget to graph it. We are not going to forget to graph it. Okay, so solve x minus 6 is greater than or equal to negative 10. Here's what you're going to do. You're going to think of that greater than or equal to sign just like an equal sign. And now the problem is exactly like chapter 1. I'm going to get x by itself because remember, solve means I want x by itself. So I'm going to have x greater than or equal to something. So I'm going to do the opposite of minus 6, and I'm going to add 6 to both sides. Now I get x is greater than or equal to negative 10 plus 6 is negative 4. And there we go. I have solved because x is by itself. I have solved the inequality. And now this looks like something I can graph. This, what we started with, did not look like something I knew how to graph. But this I can graph. Okay, so now let's graph it. We have the number we care about is negative 4. So let's put that on our number line. We know it needs a circle. Should that circle be open or closed? Well, right here we see that it is greater than or equal to, which means that it needs to be closed. Now, which way should this arrow point? Well, x is greater than negative 4, so we want it to point towards the numbers that are bigger than negative 4. So bigger than negative 4 is like anything positive. Remember, positive numbers are always bigger than negative numbers. And the positive numbers are over here. So I'm going to point towards those positive numbers. And I'm going to make that arrow nice and bold so that I know exactly which side I'm pointing to. And there you have it. We have solved an inequality using addition. It feels a lot like solving an equation with addition. Okay, let's see if we were right. Bigger than negative 4, arrows pointing that way, closed circle, we are good. Okay, more important information. Now we have the subtraction property of inequality. And again, what this means is subtracting the same number from each side of an inequality produces an equivalent inequality. So it's the same thing. If I have 8 is greater than 4, if I subtract 2 from both sides, I get 6 is greater than 2, and this is still true. 6 is greater than 2, just like 8 is greater than 4. So, same thing, just like in chapter 1, and just like with our addition property of inequality. So now, you know it, let's try some problems for ourselves. So, solve each inequality and graph the solution. So before I forget, I'm going to put number lines down here so that we don't forget anything. We don't forget to graph. Okay, if you think you know how to do this, you're like, oh man, this is just like the last example, go for it. Pause the video, try it by yourself. If you're like, wait a minute, this isn't like the last example, now we're subtracting, you're fine. Watch it with me. Okay, so we have y plus 8 is less than or equal to 5. Remember, I want to get y by itself because that's what it means to solve. So the opposite of plus 8 is minus 8. Get rid of the 8 on that side, and now I have y is less than or equal to 5 minus 8 is negative 3. So y is less than or equal to negative 3. This is the solved inequality. This is solving, but now I also need to graph. So I'm going to put 0 on here. I'm going to put the number we care about on here. I need to put a circle with the negative 3, and because it is less than or equal to, this circle is going to be filled in. Now, which way does this point? Y is less than or equal to negative 3. So, less than, numbers that are less than negative 3 are going to be more negative. If they are less than negative 3, they're going to be like negative 5 or negative 8, something like that. And that is going to point this way. So I need to point in the direction of the numbers that are less than negative 3. Ta-da! All right, we have graphed, so we are done with part A. Let's move on to part B. Now, we have negative 8 is less than 1.4 plus m. Now remember, I want to get m by itself, so I need to do the opposite of that positive 1.4, which is negative 1.4. So I'll subtract those from both sides. And now, let's see, negative 8 minus 1.4 is negative 9.4 less than m. And there we go. We have solved it because m is by itself, so we have solved the inequality, but now we need to graph it. So we're going to have 0. We're going to have the number we care about, negative 9.4. We're going to put a circle on 9.4, and we are going to leave it open because it is just less than, not less than or equal to. Now, which way should the arrow point? Well, m is bigger than 9.4. Or excuse me, negative 9.4. Negative 9.4 is less than m. We can also think about this as m is bigger than negative 9.4. So you can read it, you can kind of, it's like you can read it left to right, or you can read it right to left. So, negative 9.4 is less than m. So, negative 9.4 is less than what? It's less than, because it's negative, 9.4 is negative, so it is less than positive numbers. And m is bigger than negative 9.4, so numbers that are bigger than 9.4 are positive numbers. So our arrow is going to point towards positive numbers. Now remember, the inequality sign was pointing this way, but our final answer points the other way. That's because the variable is on the right side. It's also because, if you think about it, logically, m needs to be bigger than 9.4, and the numbers over here are the numbers that are bigger than 9.4. We have solved, we have graphed, we are finished. So, let's check and make sure we were correct. Less than negative 3, boom. Greater than negative 9.4, boom. So yeah, you can also switch it around. If you're like, ooh, the variable's not on the left, this is confusing, you can just pick the whole thing up and turn it around, and that will be just fine. So yeah, m greater than negative 9.4, boom. We are done. Okay, that's all I have for you today. Solving with addition and subtraction, section 2.2. If you had questions about anything that we did in this video, call a friend, maybe rewatch the part of the video. You can pause it, you can rewind it, talk to your teacher, comment on this YouTube video, but get those questions answered. All right. Here are some practice problems. If you'd like to try them on your own, make sure that you truly, really understand what happened in this video. You can try these practice problems. And of course, our lunch comes from E.E. Cummings, and it says, "The most wasted of days is one without laughter." Wasted without. Laughter means you're having fun. And why waste a day without having fun? And I know some days are just not fun days, but even if like crazy stuff happens, you can find a way to laugh at it. So, day without laughter is just wasted. Even if like crazy stuff is going on, you spilled coffee on your shirt, you're late for school or something, laugh about it. You know, oh, haha, this is going to be a good story later, but I'm going to catch up on all the homework. Like if I was late to school, I'm going to catch up on what I missed. If I spilled coffee on my shirt, I'll wash it off, and even if it stains, I can get a new shirt. It's just a shirt. Ha ha ha. Isn't this silly? Laughing about it, sometimes better than crying about it. Sometimes you just need to cry, and I'm not saying never cry, always laugh. That's not what I'm saying. Sometimes you do just need to cry it out. But laughter, if you can laugh at it, laugh at it. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.